So we'll start with the topic of data confidentiality and audit. So we were looking at the 10 obstacles and 10 opportunities, and this is one of the 10 obstacle and 10 opportunities. So previously we have seen availability of service, data lock-in, and data confidentiality and auditability. So we are at the third point. So we have seen already discussed availability of service. We had already discussed about data lock-in. Now we are going to discuss about the data confidentiality and audit. So what does it mean? Some of the organization have very sensitive data, which actually they rarely want to keep on the cloud, and they are very keen about and very skeptic about how to keep those data on cloud or not. So there's need of proper some encryption techniques. Virtual private networks are should be proper. Network middle box should be proper for firewall and packet filtering. All these things are very properly should be done. So encryption of data is like some of the cloud have even more secure than the local data center. So means what does it mean? So some of the encrypted data that you'll put in the public cloud is more safe as compared to encrypted data in the local data center. So in local data center, anybody can go physically over there who's interested, and they can collect the data and then try to do some decryption for that encrypted data. So unencrypted data at local data center is very highly unsecure. Means anybody physically can go and take the pen drive and take out some of the unencrypted local data and then start uh, doing some malicious activity. So it's better that you keep the private data on public cloud. It's one of the safest way because nobody can go physically over the public cloud for taking out the data. Then auditability means there are various cloud auditors that actually take care of this auditability, and it is one of the additional layer, and we'll study this cloud auditing in detail in the next unit. Then there are many nations which actually have laws related to software as a service provider, and there are various copyright issues. There are various national borders or customer data and materialistic point of view for managing the things. So some businesses are may not be like ability of a country to get access to their data. So they some businesses are like they actually make such a system in their country that the data could not be accessed from other countries, and they make such a secure system that from outside the country some other person can't be able to access that particular data. For example, in European customer might be concerned about using the software as a service in the United States. Why? Because European customers was thinking that they'll save their private data on the software as a service of United States. So United States company can use their private data for marketing purpose and other things. Then there is flexibility to the place where it has to be stored. And for example, like in Amazon, the provider actually keep the data in whichever chosen physical way in the United States and Europe. Then there is data transfer and bottleneck. For data intensive applications, there's data placement, data transport across the boundaries of cloud may be complicated. So there are various issues that may arises when you have to transfer the data over the network layer. Means there are some data is very intensive to the application. It's very hard to just transfer over the network. There may be some transport layer issue in the network. There may be some boundaries of cloud issues, in security privacy issues are there. Then what is the other form of doing data transfer? So that another way of doing the data transfer is just copy pasting that on some hard disk and transferring that data over physical medium. Means you can ship that hard disk to one center to another center. For example, this is numerical, which says that assume that you have a very high cost of internet transfer and it is better to ship that disk. Means the content itself is copied and transferred to some physical way. Means transportation, truck, car, or some ship or some train. These are the physical medium of transfer, and you just transfer that hard disk. And so there's a numerical for this. Assume that we want to ship 10 terabytes from X to Y. Suppose measured bandwidth average found to be 20 megabits per second. So what does it mean? It means it will take too much time if you transfer that data over internet, but it will be easier for you to transfer that data through some physical medium like truck, bus, or car, or some train or ship. Why? Because if you start calculating, it would take 10 cross 10 to the power 12 bytes divided by that 20 megabits per second. So you just put the values of 10 terabyte and 20 megabits per second, and you'll get the this large number of seconds to take to transfer the whole amount of data from one place to another. So it will take 45 plus days. What does it mean by 45 plus days? Means it's very long time, and it will require very high network transfer fees for this data. So it, so the time consuming as well as the cost consuming over the network. So it is better that you go for physical medium transfer. The data transfer bottleneck basically means you put data in the cloud and provide services that needs to purchase of cloud computing cycles, thus reduce the bottleneck. So data transfer bottleneck, we are continuing that part. There are three ways which actually reduces the bottleneck. First one is large public data set. Means some of the hosted data sets are like census data, images, and free that actually data set that actually attract the customer to purchase cloud compute cycle. Means what does it mean? Cloud compute cycle means you put the data on the cloud and you ask the customer to pay for this cloud compute cycle. What is means by cycle? Cycle means CPU time, means how much CPU has been used, what are the time duration a customer is using that cloud. Why? Because you put that important data over your cloud. So they have to access that cloud. So example of such data sets are like sensors data, images, etc. So these are hosted over large public data sets that actually attract some customer to pay for the usage of that and accessing that data set using some cloud compute cycle, means CPU time it will take. Then for backup services, what does it mean by backup services? Some of the companies actually do more data to send than as compared to they have to receive. Means what? Some company have to send too much data to the customers and they have very less amount of data to be received. So in the weekend, what they can move to do is full backup by doing the shipping through some physical medium. What is that shipping physical disk? Means some truck could be used, some bus could be used for transferring the data from one place to another. So in that way, the backup services could work. So because we are talking about such a large big data for management, for achieved data, for archived data, what do we? So this is the third type of bottleneck problem could happen, and third opportunity possible for archived data means in the cloud and services could result in selling of the cloud computing cycle that we had discussed in the first point. So it could be better if you create some proper searching index for the archival data and do the performance of image recognition and doing the archived photos. So if you are able to make a proper indexing of the archived data, then it would be efficient and easier for you to search, for your customer to search, and better you can better way sell out the cloud computing cycle. Then performance unpredictability. What does it mean by performance unpredictability? So it is like sharing of the CPU and memories through some virtual medium. So there are various unpredictable situations that happens during the performance, and but when we need to share some input output efficiently, then it is not that easy to do. So what it means, we have to do the proper sharing of CPU, proper sharing of memory through some virtual machines. But there's need of proper sharing of input output efficient data set and other things. Then it is not that easy for you to do IO efficient sharing. So what does it mean by whole point? If you want to do the CPU sharing or memory sharing through some virtual machine, then you have to write efficient code for doing IO based sharing. So this is one of the issue that you have to solve, means writing proper driver code for IO efficient code for sharing. Then scope of improvement of in interrupt and IO management in cloud computing. So there are various ways in which flash drives, semiconductor memories that are possible solution could be used for doing the interrupt and IO management in cloud computing. Then there are various scopes in batch processing deployment at virtual machines. So this deployment over the uh, over the virtual machines could be possible and to do the batch processing. Then there is also a scope of visual cloud processing which can actually monitor and show the running thread of the program concurrently. So there are various things that could be possible to do for cloud processing efficiently and showing the running thread of the concurrently running programs. Okay, then there's one more thing, that this is scalable storage. So scalable storage is also an issue as well as benefit. What is the issue and what is the benefit? So it is how to apply short-term usage and no upfront cost and infinite capacity on demand to persist the storage. So this is a challenge, how to write such codes and how to develop such infrastructure that could have some short-term usage, means very less time some of the data was being used, and there have to be no upfront cost, means no immediate cost, means it would be easy to have as many user as possible. Then it has to be illusion that there is infinite capacity for demand by the customer, and all these things have to be done for the persistent storage. So there are various ways and various techniques that are required to be done. So there is, for example, varying in richness of query and storage of APIs. So if some very better APIs are there, better codings are there, so it's easy for doing such efficient storage. Then there is performance guarantee, means there is a condition where you can have better and better guaranteed result. Then there is complexity of data structure that are needed to be support directly on the storage system. Some schemaless and column oriented storage are there. So it is also how complex is your data structure for storage purpose, like there are XMLs and JSON type of formatting are being used for storage. Then you have to create some of the stored system that actually do not meet such a high scaling attribute and up or down on demand. So it means that you have to make such an efficient APIs, and that could able to meet out some of the cloud advantages, which the advantages like there is some uptime and some downtime, means sometimes the cloud is not able to perform according to the demand, but you have to make that efficient API that can perform the cloud well and come back in the availability as soon as it is down. So so the programmer has a lots of expectation regarding such resource management and for scalability, data durability, and high availability. So that's what I'm saying. It is part of both infrastructure manager and programmer to meet out such an expectation of a scalable storage through some resource management which are required for the scalability, durability, and availability. Thereafter, bugs in large scale distributed system. So there there are such large cloud computing systems which are very large scale in nature and which are distributed system, and it's very difficult for a programmer to remove such errors because they work on network. So you have to find out bugs properly on such a distributed system, and you have to remove those bugs. So these are the challenges of cloud computing over the large scale distributed system. Then these bugs are basically not easy to be reproduced in the similar configuration. In the means these bugs are not able to be reproduced in smaller configuration. What does it mean? Means if a bug occur in the larger configuration, then you have to troubleshoot that bug in that larger configuration itself, and you can't create or simulate that same bug in the smaller configuration. So if there is a bug that you can simulate on the smaller configuration, then you can remove that bug. But in case of condition where you cannot replicate such a bug, which is only happens in large scale configuration, so you can't, it's very difficult to do the debugging of such bugs. Thus most of the time debugging occurs at data center. So data center it's means the large amount of time is required for such a debugging. Then scaling quickly means, so pay as you go model. It's very common in cloud computing. What does it mean? It means applying some certain CPU time that you are using, that customers are using, storage or network bandwidth that customer is using. So it has to be scalable, and as much as required, the provider have to manage that resources. Then scale in resource to load increase or decrease without violating some service level agreement. So there's requirement of maintenance of service level agreement and providing proper scaling for the load increase or decrease irrespective of how you need to manage, so that s- that service level agreement or SLA would be maintained. So for example, some Google app engine, some users are being charged for the CPU cycles. For example, in the Amazon, the charges for the customer are based on the hourly basis, that how much hour they are using some particular instance. Then reasons for scaling is to conserve the resources as well as memories. What does it mean? So the purpose of all these scaling is to conserve the resources. Means if one data center is idle, means there's no much user, so they could, the other data center is been full with the customers and users. So the load of one data center could be transferred to the load of another data center, and that will actually conserve the resources of both the data centers, and which will actually also optimize the money. And the idle computer could be used by the two third party systems, and that could have the better business could be possible for busying that computer. Means if there's one computer which is idle, so you can have a program which could be written, and you can give its CPU cycle to the another customer, and you can earn out of it. Thus you can optimize such idle computers, and that can reduce such data center cost. So for example, some of the programmers may need some pay attention and efficiency per cycle. So programmers actually need some better way for the efficient CPU cycle, and so, all the programmer have to write the code very properly, and do not have to work efficiently, so that the efficient CPU cycle could be shared. Then sometimes it is better to leave machine idle overnight to avoid reconfiguring the work next day. So in the large data center, it is said to be that you just leave your machine as it is, and do not s- shut down it, so that you can, in the night it will be just on the sleep mode, and when you come another day, so it will start from the same place. Means no reconfiguration is required next day. So this is one of the way. Then there's reputation, fate sharing, software licensing, and opportunities in cloud and conclusion that we'll discuss in the next class. So we'll start from the reputation fate sharing tomorrow in the next class. Thanks all of you.